Darkness, infinite, cold void, which is only occasionally pierced by the cold light of distant stars. For over 50 years, we have looked at our silvery satellite as a museum exhibit, a place where the first human steps were once imprinted, but which remained in the past. However, today the silence around the moon is being broken. The Artemis 2 mission is not just another flight around the moon. It is not just a return. It is the most complex scientific test in the history of humanity, the true purpose of which is hidden behind official press releases about testing systems. While the world watches four brave astronauts preparing to challenge the infinity, the real questions remain in the shadows. Why are we returning exactly now? What invisible threats of deep space are we going to explore with the help of the Orion spacecraft? Could it be that Artemis 2 is only a preparation for something much larger than the colonization of the moon? We will dive into the data of the National Aeronautics and Space Administration, study the reports of the European Space Agency, and analyze the results of the James Webb Telescope to understand. The moon is not the finish line. It is only a testing ground for technologies that will allow humanity to become an interplanetary species. Prepare yourselves, for what we learn will change your perception of the place of Earth in the universe. On the 12th of December 1972, Eugene Cernan, the commander of the Apollo 17 mission, lifted his foot from the surface of the moon, leaving the last human footprint to date in the dust of another world. Before entering the lunar module, he uttered words that today sound like a prophecy. "We leave as we came, and God willing, we shall return, with peace and hope for all mankind." Back then, in the midst of the 70s of the 20th century, no one could imagine that this return would stretch for long 50-plus years. Why did humanity, possessing technologies that allowed 6 successful landings on the satellite of the Earth, suddenly stop at the very threshold of great discoveries? To understand the scale of the Artemis 2 mission, we must first understand the anatomy of the hull of the Apollo program. In the 60s, the space race was not so much about science as it was about ideological dominance and the demonstration of technological might in the conditions of the Cold War. The Apollo program was a child of its time, incredibly expensive, risky, and focused on one goal: to outpace the Soviet Union. When the flag was planted and the regolith samples were delivered to Earth, political interest began to fade. The administration of President Richard Nixon faced economic difficulties, the war in Vietnam, and social upheavals within the United States of America. As a result, the funding of the National Aeronautics and Space Administration was sharply reduced, and the last planned missions, Apollo 18, 19, and 20, were forever canceled. During the following decades, the vector of space research changed radically. Humanity focused on low Earth orbit. The era of reusable space transportation systems like the Space Shuttle and the construction of the International Space Station gave us invaluable experience of long-term human presence in weightlessness. We learned to live in space, repair satellites, and conduct complex biological experiments. However, all this time we remained under the protective dome of the magnetic field of the Earth at an altitude of only 400 kilometers. The moon, located at a distance of 384,000 kilometers, again became only an unattainable disk in the night sky. But science did not stand still. While humans did not fly to the moon, robots flew there. Missions such as Cassini, Galileo, and especially the Lunar Reconnaissance Orbiter changed our perception of the satellite. Previously, the moon was considered an absolutely dry and dead world. However, data obtained at the beginning of the 21st century confirmed the presence of water ice in deep craters at the poles where the sun never looks. This discovery changed everything. Water is not just a means for the survival of astronauts. It is hydrogen and oxygen. It is fuel for rockets. The moon stopped being just a rock. It became a potential refueling station on the way to distant planets. In the year 2004, President George Bush Jr. announced the Constellation program, which aimed to return people to the moon. However, due to budgetary problems and changing political priorities, the program was canceled by the administration of Barack Obama in the year 2010. This was a critical moment. It seemed that the dream of deep space was finally buried. However, it was then that the foundations of what we today call Artemis began to be laid. It was decided to preserve the development of the new Orion spacecraft and the Super Heavy rocket, which later received the name Space Launch System. The current context of the return to the moon is radically different from the era of Apollo. Now, it is not just a competition between two superpowers. It is the beginning of a new space economy. Private companies, such as SpaceX of Elon Musk and Blue Origin of Jeff Bezos, have entered the game. Furthermore, the People's Republic of China is actively developing its lunar program, planning the construction of its own base. This creates a new dynamic, a mixture of scientific cooperation and geopolitical rivalry. The Artemis program, named after the twin sister of Apollo in Greek mythology, symbolizes continuity and evolution. If Apollo was about visit and leave, then Artemis is about come and stay. Artemis 1, which took place in the year 2022, proved that the Space Launch System is capable of launching the Orion spacecraft into lunar orbit, and the spacecraft itself can withstand the hellish temperature during re-entry into the atmosphere. Now, Artemis 2 must take the next, most critical step, to entrust the lives of people to this technology. We must realize that the historical gap of 50 years was not a time of stagnation. It was a time of accumulating knowledge. Now, when we are armed with data from the James Webb Telescope about the formation of star systems and decades of experience working on the International Space Station, we understand that the moon is the eighth continent of Earth, and the Artemis 2 mission is the key to opening the doors of this continent. We are returning not because it is easy, but because it is necessary for the survival of our species in the long-term perspective. Every detail of past missions, every mistake, and every success of Apollo became the foundation on which Orion stands. But the scales of challenges facing the crew of the second Artemis significantly exceed everything that Neil Armstrong or Buzz Aldrin encountered. For they flew into the unknown, and we fly to build a future there. This historical path from the first telescopic observations of Galileo Galilei to the ultra-modern laser communication systems of Orion demonstrates the unceasing thirst of man for expanding his borders. We have come a long way from myths about lunar gods to detailed geological maps of every square meter of the lunar surface. However, despite all the knowledge, the moon remains a place where the laws of physics reign, hostile to everything living. And to understand exactly how Artemis 2 is going to tame these laws, we need to dive into the scientific base of the mission, where every gram of fuel and every millimeter of the hull matters. When we talk about the return of humanity to the moon, we often imagine majestic shots of takeoff or boot prints in the silvery dust. However, the true magic of Artemis 2 is hidden in metal, composite materials, and millions of lines of software code. To send 4 people to a distance of almost 400,000 kilometers from their home planet and, most importantly, to return them alive, engineering thought had to perform a quantum leap. The central element of this architecture is the most powerful rocket in history, the Space Launch System, and the most advanced manned spacecraft of modernity, Orion. Imagine a structure 98 meters tall. That is taller than the Statue of Liberty. When the Space Launch System stands on Launch Pad 39B at the Kennedy Space Center, it looks like an immobile colossus. But at the moment of ignition, it turns into the embodiment of controlled chaos. At its base lie 4 RS-25 engines, which have a glorious history, for they once lifted space shuttles into the sky. However, for Artemis, these engines were modernized to withstand even greater loads. They work on liquid hydrogen and liquid oxygen, creating incredible thrust, but even they are not enough to overcome the gravitational shackles of Earth. The real power is hidden in 2 white solid fuel side boosters. Each of them is taller than a 15-story building. Together, they create over 3,800,000 kilograms of thrust. This is power that is difficult for the human mind to comprehend. If we could convert this energy into electricity, it would be enough to power an entire large city for many hours. During the first 2 minutes of flight, these boosters burn 6 tons of fuel every second. This is the moment of maximum dynamic pressure, when the construction of the rocket feels colossal forces of atmospheric resistance. After the first stage completes its work and falls into the ocean, Orion takes over. A spacecraft that is a true technological miracle. Orion consists of two main parts, the crew module and the European service module. The crew module is developed by the Lockheed Martin Company. Although it resembles the capsule of the Apollo missions from the outside, inside it is a 21st century spacecraft. It is significantly more spacious than its predecessor. The volume of pressurized space is about 9 cubic meters, which allows 4 astronauts to work and live in it for 21 days. One of the most critical systems of Orion is the launch abort system. It looks like a thin white tower on top of the spacecraft. In the event of any anomaly on the launch pad or in the first minutes of ascent, the engines of this system are capable of tearing the capsule with the crew away from the rocket in fractions of a second, accelerating it to a speed of 700 kilometers per hour in seconds to take the people to a safe distance from a potential explosion. This is an insurance policy that the engineers of the National Aeronautics and Space Administration hope will never be used, but its presence is a mandatory condition for safety. The contribution of the European Space Agency deserves special attention. The service module created by the Airbus company. This is the heart and lungs of Orion. It provides the spacecraft with electricity using 4 solar arrays that unfold in the shape of a cross and resemble wings. These panels are capable of generating enough energy to provide for the operation of 2 average households. In addition to energy, the service module carries reserves of water, oxygen, and nitrogen for the crew, as well as the main engine, which will perform maneuvers for entering lunar orbit and returning home. One of the most difficult engineering challenges is the return to Earth. Orion will enter the atmosphere at a speed of about 11 kilometers per second. That is 40,000 kilometers per hour. At this moment, friction against the atmosphere will heat the heat shield of the spacecraft to a temperature of 2,760 degrees Celsius. That is half the temperature of the surface of the Sun. To withstand such hell, the shield with a diameter of 5 meters is covered with a special ablative material called avcoat. During heating, this material gradually chars and burns away, diverting heat from the hull of the spacecraft. This is the only barrier separating the astronauts from the incinerating heat of the plasma outside. The digital contents of Orion are also impressive. Its onboard computers have many times more computing power than those used on the International Space Station. However, in space, the main thing is not the processor speed, but its reliability. Electronics must be protected from harsh cosmic radiation, which can cause errors in the code. Therefore, the systems of Orion are duplicated many times. Every command is checked by several independent computers, and if one of them shows a different result, the system automatically excludes the erroneous link. Why such complexity? Because Artemis 2 is not just a flight in a circle. It is a test of the system in the real conditions of deep space. Unlike the International Space Station, which is located only 400 kilometers from us and where a cargo ship can reach in a few hours, Orion will be an independent unit, hundreds of thousands of kilometers from home. Any malfunction of the air regeneration system or a short circuit in the power system could become fatal. That is why every valve, every wire, and every bolt in the space launch system in Orion underwent thousands of hours of testing in vacuum chambers, on vibration stands, and in conditions of extreme temperatures. When we look at these blueprints and technical specifications, we see not just a machine. We see thousands of hours of labor by engineers from 35 countries of the world. This is a global project where the precision of measurements reaches micron values. After all, in space, there are no small things. Every gram of saved weight allows for taking more scientific equipment or fuel for maneuvers. When the Orion spacecraft crosses the mark of 1,300 kilometers above the surface of our planet, the crew of the Artemis 2 mission will face an invisible and deadly enemy, whom we have not met up close for over 50 years. This is not a technical malfunction and not a meteorite threat. It is the ionizing radiation of deep space. In low Earth orbit, where the International Space Station operates, astronauts are still protected by the magnetosphere of Earth, a giant invisible shield that deflects most charged particles. However, heading to the Moon, Artemis 2 must pierce this shield and go out into the open ocean of radiation, where the rules of survival change radically. The first major obstacle on the way will be the Van Allen belts. These are two zones in the shape of toroids where the magnetic field of the Earth traps and holds high-energy particles, mostly protons and electrons arriving from the Sun. Passing through these belts is a short but intense procedure. Engineers of the National Aeronautics and Space Administration calculated the trajectory of Orion in such a way as to minimize the time spent in the most concentrated radiation zones. But even under such conditions, the crew will receive a radiation dose that significantly exceeds any terrestrial background. This test is critical, for Artemis 2 is the first mission where we will measure the impact of these belts on a living organism using the most modern dosimeters integrated directly into the equipment and clothing of the astronauts. The scientific community, in particular the authors of studies in the journal Science, highlight two main types of radiation threat outside the terrestrial magnetosphere. The first is solar proton events. Our sun is a restless reactor that from time to time ejects colossal volumes of plasma and high-energy particles. If a powerful solar flare occurs during the flight, Orion will turn into a target in a cosmic shooting range. To protect against such cases, a so-called storm shelter is provided inside the spacecraft. Astronauts must move to the central part of the living module, surrounding themselves with water containers and food supplies. Water, thanks to its high hydrogen content, is one of the best natural barriers for stopping protons. The second type of threat is much more insidious. It is galactic cosmic radiation. These are particles that arrive to us from beyond the solar system, born by the explosions of supernovae. They have incredible energy and move at a speed close to the speed of light. The problem is that it is practically impossible to fully protect against galactic radiation with a metal hull. When such a particle hits the aluminum hull of the spacecraft, it breaks the atoms of the metal, creating a whole cascade of secondary radiation, neutrons and X-rays. This phenomenon scientists call secondary ionization, and it can be even more dangerous than the primary hit. How does this affect human biology? Every cell of our body is a complex microcircuit where the main carrier of information is the deoxyribonucleic acid molecule. High-energy particles act as microscopic bullets. They can cause both single and double breaks in DNA strands. If a cell is still capable of repairing a single break on its own, then massive damage leads to mutations or cell death. A particular concern among the doctors of the National Aeronautics and Space Administration is the impact on the central nervous system. Studies published in the journal Nature show that long-term exposure to heavy ions can impair cognitive functions, memory, and the ability to make quick decisions, which is unacceptable during the operation of a spacecraft. In the Artemis 2 mission, the crew will use special astrorad vests developed jointly with Israeli and German specialists. These vests protect the organs most sensitive to radiation, the bone marrow, stomach, and reproductive system. This is not just clothing, but a complex composite shield that mimics the density of human tissues to absorb the energy of particles before they reach the body of the astronaut. During the Artemis 1 mission, two mannequins, Helga and Zohar, already traveled on board Orion, equipped with thousands of active and passive sensors. The data obtained from them became the foundation for developing safety protocols for the living crew of Artemis 2. In addition to radiation, there is another biological challenge: microgravity combined with isolation. Although 2 weeks of flight is not 6 months on a station, the sharp change in gravity affects the redistribution of fluid in the body. Blood rushes to the head, causing the so-called puffy face syndrome, and the cardiovascular system must instantly adapt to the fact that it no longer needs to pump blood upward against the force of Earth's gravity. This creates stress on vision, as increased intracranial pressure can deform the eyeball, a phenomenon known as neuroocular syndrome. The Artemis 2 mission is essentially a large biological laboratory. Every breath of the astronauts, every heartbeat, and every change in their blood will be carefully documented. We are gathering data not just to fly to the moon, we are gathering it for the future journey to Mars, which will last not weeks but years. Understanding how to protect the human body from cosmic radiation and tissue degradation is the key to becoming a true cosmic species. Every member of the crew, Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, realizes that their bodies will become the source of the most valuable scientific information in the history of deep space medicine. We must remember that space will never become a friendly environment for us. We will always be only guests there, protected by a thin shell of technologies. However, it is precisely our desire to overcome biological limitations that makes us human. Artemis 2 will prove whether we are ready to go beyond the limits of our cradle and withstand the test of the stellar wind, which has lasted for billions of years. When we look at the full moon from Earth, it seems to us a homogeneous silvery disk, dotted with dark spots of ancient lava seas. However, for scientists from the National Aeronautics and Space Administration and their international partners, the most intriguing part of our satellite is hidden where sunlight almost never touches the surface. This is the South Pole, a place that has become the true gold rush of the 21st century. The Artemis 2 mission, although it is a flyby, aims for careful study of exactly this region, for it holds the key to the entire future of humanity in deep space. Why exactly the South Pole? The answer lies in the unique topography and physics. Because the axis of rotation of the moon is tilted by only 1.5 degrees, the solar rays fall on the poles at a very low angle. This creates the phenomenon of craters of eternal shadow. Inside these deep abysses, such as the Shackleton crater, the sun has not risen for billions of years. The temperature there drops to minus 230 degrees Celsius. This is colder than on the surface of Pluto. It is in these natural cosmic freezers that scientists discovered what was previously considered impossible on the moon: colossal reserves of water ice. Evidence for the existence of water on the moon has been accumulating for decades, but the final breakthrough occurred thanks to data from the Lunar Reconnaissance Orbiter and the dramatic experiment of the L-Cross mission in the year 2009. Then the National Aeronautics and Space Administration intentionally directed the upper stage of a rocket into one of the shadowed craters, and the satellite flying behind analyzed the raised cloud of dust. The results were sensational. Pure water was detected in the composition of the dust. Later, instruments of the Indian Chandrayaan-1 mission and data from the Sophia Stratospheric Observatory confirmed that water on the moon is not a mirage, but a strategic resource. For the crew of Artemis 2, the South Pole will become the main object of observation during the closest approach to the surface. Why is this ice so important? If we want to build a permanent base, we cannot constantly bring water from Earth. Delivery of 1 liter of any cargo to the moon costs tens of thousands of dollars. But water is much more than just a drink for astronauts. Using electrolysis, we can split a water molecule into oxygen for breathing and hydrogen, which is the most efficient rocket fuel. In this way, the South Pole of the moon turns into the first cosmic gas station. Ships flying to Mars will be able to start from Earthlight, refuel in lunar orbit with resources extracted from craters, and continue their way into deep space. In addition to water, the South Pole offers another priceless resource: peaks of eternal light. These are elevations in crater rims that, due to the same geometry of the axis, are almost constantly illuminated by the sun. These are ideal places for installing solar power plants that will provide the lunar base with uninterrupted energy, unlike other regions of the moon, where the night lasts 14 terrestrial days. Artemis 2 must confirm the accuracy of our illumination maps, so that future landing modules of Artemis 3 can land with surgical precision. However, the extraction of these resources is not only an engineering, but also a scientific task of incredible complexity. Reports of the European Space Agency state that lunar regolith mixed with ice resembles concrete in its hardness. How will mechanisms work at temperatures close to absolute zero? How to avoid contaminating the ice with the exhaust gases of landing engines? These questions are now being discussed at the highest levels in scientific journals, such as Nature Geoscience. The Artemis 2 mission will also explore the geological anomaly of the South Pole, the huge South Pole Aitken Basin. This is one of the largest and oldest impact craters in the entire solar system, with a diameter of about 2,500 kilometers. Exploring this region will allow for looking inside the lunar crust and understanding how our satellite and Earth itself were formed billions of years ago. The Japan Aerospace Exploration Agency is already preparing joint missions with India to explore this zone, and data from Orion will become a roadmap for them. We must understand that the struggle for the South Pole of the Moon is not just scientific interest. It is the beginning of a new era of geopolitics, or astropolitics. The country or coalition that is the first to establish itself on these strategic heights and gain access to ice will dictate the conditions for space exploration in the next century. This is why Artemis 2 carries such a heavy burden of responsibility. It is not just a check of the spacecraft systems, it is a demonstration of presence and intentions. Every photograph taken by high-resolution cameras from onboard Orion, every laser scanning of the terrain, brings us closer to the moment when the first woman and the next man will lower their landing legs into the cold dust of the South Pole. We are returning to the moon not for the sake of flags, but for the sake of ice, which will become the foundation for our civilization beyond Earth. The 65th minute of our dive leads us to where the era of solitary flights ends and the epoch of permanent human presence in deep space begins. If the Apollo missions were similar to short sorties of mountaineers who set up a tent, conquer the peak, and hurriedly run back down, then the Artemis program is the construction of a full-fledged high-altitude camp. And the central hub of this camp will be the Lunar Gateway, the first space station in human history that will orbit not our planet, but the moon. For the crew of Artemis 2, this issue is fundamental because during their flight, they will test communication and navigation systems that in the future will become the basis for docking with this station. The Lunar Gateway is not just a reduced copy of the International Space Station. It is an absolutely new type of engineering structure that must operate in conditions of a much more aggressive environment than low Earth orbit. There is no protection of the magnetosphere here, and the distance to Earth is 1,000 times greater than to the International Space Station. This means that the station must be almost completely autonomous. One of the most impressive aspects of the Lunar Gateway is its unique trajectory, a near rectilinear halo orbit. Why did the scientists of the National Aeronautics and Space Administration choose exactly it? This was the result of complex mathematical calculations that took into account the gravitational interaction of Earth and the Moon. In this orbit, the station will pass only 3,000 kilometers from the south pole of the Moon at the closest point, and at the farthest point, it will move 70,000 kilometers away. Such an elliptical loop allows the station to always remain in the zone of direct visibility of Earth, which guarantees uninterrupted communication. Moreover, the station will constantly be under solar light, which provides it with energy and allows for avoiding extreme temperature drops in the lunar shadow. The construction of the gateway will begin with two key modules. The first is the power and propulsion element, which is being developed by the Maxar Technologies company. This is the heart of the station, equipped with the most powerful solar electric propulsion system in the world. It works by accelerating xenon ions using an electric field. Although such thrust is small compared to chemical rockets, it can operate for years, allowing the station to adjust its orbit with minimal fuel expenditure. The second module is the Habitation and Logistics Outpost, created by the Northrop Grumman Company. This is the place where astronauts will live, conduct scientific experiments, and prepare for landing on the surface. The international scale of this project has no analogs. The European Space Agency is responsible for the IHAB module, which will provide additional living space and a refueling system. The Japan Aerospace Exploration Agency provides life support systems and logistics. The Canadian Space Agency creates Canadarm3, the next generation of intelligent robotics. This manipulator system will be equipped with artificial intelligence, which will allow it to independently maintain the station when there is no crew on board. This is critically important, for the Lunar Gateway will not be inhabited constantly like the International Space Station. It will host crews only for a few months a year. Why are we not building a base directly on the surface? This is a strategic question. The Lunar Gateway performs the role of a command center and a port. It allows for safely accumulating resources and equipment. In addition, from orbit, it is much easier to control robots on the lunar surface in real time, avoiding the signal delay that occurs during transmission from Earth. Reports from the European Space Agency emphasize that the Gateway will become a laboratory for studying how deep space affects materials, electronics, and microorganisms over long periods of time. However, the true significance of the Lunar Gateway goes far beyond lunar orbit. It is a prototype of a ship for the journey to Mars. The technologies being tested here, from closed loops of water regeneration to autonomous system management, are the same technologies that will be needed during a 3-year expedition to the Red Planet. Artemis 2 is a prelude to this great development. Every signal transmitted from onboard Orion through the Deep Space Network checks the readiness of the infrastructure, which will soon become a permanent outpost of humanity. We must understand that construction in deep space is a logistical nightmare. Every screw, every gasket must be delivered hundreds of thousands of kilometers away. Therefore, the Gateway is created as a modular system that can be expanded for decades. In the future, commercial modules for tourism, scientific laboratories of private companies, and warehouses for fuel extracted from lunar ice may be added to it. When the astronauts of Artemis 2 are flying past the moon, they will look at the empty space where in a few years a bright point of the station will appear. This will be the first light of humanity in the true darkness of space. The Lunar Gateway will become a place where nations meet, where science overcomes borders, and where we finally learn to be not just residents of one planet, but citizens of the solar system. This is the infrastructure of the future. This is the most reliable bridge we have ever built. And in the next chapter, we will talk about where this bridge leads us in reality, to the great journey to Mars, and those challenges that force us to rethink the very essence of human nature. We have reached the 80th minute of our journey, where the event horizon expands from the silvery craters of the moon to the rusty deserts of Mars. For many critics and ordinary observers, a logical question arises. Why spend billions of dollars on returning to where we already were 50 years ago? The answer that the National Aeronautics and Space Administration gives in its strategy from the moon to Mars is unequivocal. We will not be able to conquer the red planet without learning to live on the moon. The Artemis 2 mission is the first large-scale test of our readiness for interplanetary leaps. Mars is at a distance that is hundreds of times greater than the distance to the moon. If a flight to our satellite lasts 3 to 4 days, then a journey to Mars with modern technologies will take from 6 to 9 months in one direction only. In the event of a critical malfunction on the way to the moon, as happened with Apollo 13, the crew has a chance to return home in a few days. On the way to Mars, such a possibility will not exist. That is why the moon becomes an ideal testing ground. Here we test systems of the closed life support cycle, which must operate for years without refueling. On board Orion during the Artemis 2 mission, prototypes of air and water regeneration systems will be tested, which will later become the heart of Martian ships. However, alternative views on this strategy exist. Fierce debates take place in the scientific community, which often end up on the pages of the journal Science. One of the most popular alternative theories is the Mars Direct concept, proposed by engineer Robert Zubrin. Supporters of this approach argue that creating expensive infrastructure in lunar orbit, such as the Lunar Gateway Station, only disperses resources and delays landing on Mars for decades. They believe that humanity should focus on the development of super-heavy launchers, such as the Starship of the SpaceX company, and fly to Mars directly, using the resources of the red planet itself to create fuel. Artemis 2 in this context is a compromise between a cautious scientific approach and an ambitious desire for expansion. Another important topic of scientific discussion is the opposition of manned and robotic missions. Many planetary scientists argue that modern rovers, such as Perseverance and future autonomous drones, can collect significantly more scientific data at a lower cost and without risk to human lives. Why send 4 astronauts of Artemis 2 to risk their health under the strikes of solar radiation if we can send 100 high-tech probes? The answer lies in the unique human ability for intuitive analysis and rapid decision-making in non-standard situations. No robot can yet compare with a field geologist in the speed of identifying the most promising rock samples. In addition to technical and financial aspects, a deep psychological problem exists, which experts in biomedicine are exploring. This is the phenomenon of detachment from Earth. During the Artemis 2 mission, the crew will become the first people in history to see our planet so small that it can be covered by the thumb of an extended hand. This causes not only admiration, but also deep stress. Studying the psychological resilience of the four astronauts, Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, will provide priceless data on how the human psyche withstands complete isolation from the home world. Will the crew be able to maintain productivity, knowing that beneath them are thousands of kilometers of vacuum, and ahead is only dead silence? Alternative theories also touch upon the issue of planetary protection. Some astrobiologists fear that a hurried dispatch of people to Mars could lead to contamination of the planet with terrestrial microorganisms. This will make it impossible for the future discovery of true Martian life if it exists there. The moon in this regard is a safe object because it is sterile. Testing sterilization and quarantine protocols on Artemis, we are learning to be responsible cosmic travelers. We also cannot ignore the role of the private sector. While the National Aeronautics and Space Administration adheres to the conservative Artemis plan, SpaceX is developing its own schedule for the colonization of Mars. This creates an interesting synergy. The state program provides the fundamental scientific base and safety, while private capital pushes technologies forward through high competition. Artemis 2 is the point of intersection of these two worlds, as landing on the surface in the following missions will be carried out using a landing module based on the Starship. Concluding this chapter, we see that Mars is not just the next planet. It is a mirror in which we see the future of our species. Artemis 2 builds a bridge across the abyss of the unknown. Every rhetorical question about the expediency of the flight, every alternative theory about using robots instead of humans, only underscores the importance of this moment. We are preparing for the greatest journey in history, and every kilometer passed by Orion on the way to the moon is a step toward the red sands that have been waiting for us for billions of years. We conclude our journey at the moment when the Orion capsule at breakneck speed cuts through the upper layers of the atmosphere, turning into a bright, fiery comet in the night sky over the Pacific Ocean. But while the astronauts feel colossal G-forces, we must realize the main thing. The Artemis 2 mission is not just another mark in the flight log. It is the moment when humanity officially ceases to be a species locked in one cradle. What we are actually testing on a large scale is not only the strength of the heat shield or the power of the rocket. We are testing our ability to be autonomous. For decades, we held on to the umbilical cord of low Earth orbit, where help is always nearby. Artemis 2 breaks this connection. This is the first step toward true independence from Earth. If Artemis 2 passes successfully, it will mean that we are ready not just to visit other worlds, but to become their inhabitants. We are returning to the moon not because we are cramped on Earth, but because the nature of life is expansion. As data from the James Webb Space Telescope show, the universe is full of possibilities, and it would be the greatest tragedy of our civilization to remain only observers. Artemis 2 is our entry ticket to the Club of Interplanetary Species. It is the foundation for the first city on the moon, for the first expedition to Mars, and finally, for the preservation of the fire of human consciousness, even when our home planet faces the inevitable challenges of the future. Today, we stand on the shoulders of giants, from scientists of the National Aeronautics and Space Administration to engineers of the European Space Agency. We have combined the resources of the entire planet so that 4 brave individuals could look at us from deep space. This look will change everything. It will remind us that despite all conflicts and disagreements, we are one team on a small spaceship named Earth, which is now building its first true port in the stars. What awaits us next? Will the 26th year become the beginning of a new golden era, or will we again step back? The answer depends not only on technology, but also on our common will to continue this movement. Please give a like and subscribe to the channel. What mystery of the universe do you consider most worthy of risking everything for it? Are you ready to support a path where man forever leaves the safe borders of his home sky? Share your thoughts in the comments, for the future of space is being written right now, and you are its inseparable part. Thank you for going through this path together with us. See you in the orbit of the future.